Green. All right, there we go. All right, last thing I have to do, I have to connect the iPad over here. All right, that worked. Get this out of the way. All right, so these problems that I've got for today are in the order that we covered them, and on the exam itself, they're in the same order. So spotting them will be a little easier, but we'll still talk about how to spot them. This first problem is binomial. And the thing that tells me binomial, the couple of things that I'm looking for finding the probability of this many out of that many. That out of number, which is n, really distinguishes a binomial problem from the rest. The other thing I'm looking for is some kind of a percentage, a probability of success, and this problem has that as well. So in this problem, we're talking about out of 8 students, find the probability at least one experiences food insecurity, and we're told that 50% report that. So we have 1 out of 8 with a 50% chance for each one. That's binomial. On the screen, I've got the 6 things that I think that you should write down each time. They're not all necessary. So for example, the 3 things that we absolutely have to know for StatCrunch are those 3, N, X, and P, the number of trials, number of successes, and the probability of success. But if you don't write down these other things, there's a problem where the percentage is actually not the percentage we want, and you won't notice that. So I'm going to fill this in. Number of trials is how many it's out of. That's out of 8. The number of successes, at least 1, we write as greater than or equal to 1. Now, some students, they see the 1 and they lock in on equals 1, but we're looking for those keywords like at least, at most, more than, less than, between. It's not always going to be exactly equal to that number, so read that part carefully. The success is what we're counting. And success is not necessarily a good thing. It's what we're counting. So in this case, it's actually a bad thing. Oops. My brother doesn't know that I work. So the success is what we're counting. And here we're counting the number of students that experience food insecurity. Now, so the success, I'm just going to write insecurity. And for failure, no insecurity. And what we've got to figure out is whether the percentage that's given, does that go with having insecurity or not having insecurity? Here it says 50% report food insecurity, so that value is P. But if it said this percent do not experience insecurity, we'd have to switch that around. In the next example, I'll do that. Probability of failure we don't really need here, but 1 minus 0.50 is also 0.50. So at this point, we can go into StatCrunch. I've already opened up the calculator. The binomial calculator is under Stat Calculators. The value of N is 8. P was 0.5, so that was okay. X, we were looking for greater than or equal to 1. And the values there in the bottom right corner, usually we round these to 4 places. In my lab, just be careful with what they ask you for. But here it's 0.9961. Also, that graph is pretty helpful. If you notice, the bars that are shaded in red let you know what you were supposed to be counting. And that's one last visual to make sure that you have at least 1. At least 1 means 1 or above. Also, that's the one that's missed the most by students. I think when we read at least, something in my mind triggers less, but it's not less, it's greater than or equal to. It's the opposite of that. Okay. At least 1 means 1 or more. Okay, the second problem, also binomial, is what I call in our face-to-face classes, I call this a switcheroo. And the reason for that is that the percentage that's given is not the actual percentage we're going to use in the problem. I read through it really quickly. I see something about 40%. I see 10 students are selected, find the probability of at least 7 are in some group. This many out of that many with a percentage is binomial. The number of trials is the number of students selected. That's 10. The number of successes, find the probability that at least 7 do not own an iPhone. So that's greater than or equal to 7. But what we're counting is the number that don't own an iPhone. The failure would be the complement of that, the people that do have an iPhone. And what we've got to figure out is, where does that 40% go? Does it go with not having an iPhone, or does it go with having an iPhone? And here it says that 40% own an iPhone. That is the probability of failure. That means that the probability of success for this problem is going to actually be 60%. If 40% have an iPhone, the rest, 60%, do not. Now we can take this to StatCrunch the same exact way. This time N was 10. P was 0.6, greater than or equal to 7. And we get 0.3823. So in the part 1 of the midterm, there's one binomial that's straightforward like the first one, and there's one where you've got to be careful that you get them switched. That's kind of dangerous knowledge, because if you switch the wrong one, you're going to get them both wrong. So be real careful that the percentage that's given matches up with what you're trying to count. And if it doesn't, then you need to take the complement instead. Now, when you write this out and you turn this in, you don't have to show all of these things that I've written down. You do have to tell me the calculator you used, which was binomial, and what you typed in. So n equals 10, x was greater than or equal to 7, and p was 0.60. Those need to show up. Now, if you're doing cut and paste into a document, so like yesterday, Tracy was talking to me about making all her graphs in StatCrunch and putting all her graphs into one Word document. You could copy the entire calculator and paste that into a Word document or Google document, and that would be fine as well. To make that copy, it's just under Options, Copy, and then you can right-click to copy that if you're working with Windows. I don't know the command for Mac, but I think it's probably like that Apple sign and V or something like that.
Oh, yeah. No, yeah, I have Windows.
Or commit, yeah, good. All right, so those are the two binomial problems. You'll see a couple more in the part 2 part. They're pretty straightforward. Let's move on and try some Poisson problems next. So I'm gonna hide the binomial calculator. The Poisson calculator is similar, right? In the bottom row, it's just like the binomial calculator, but up top, all we need is the mean. There's no value for n and p. And this is your other advantage when you're trying these problems. If you're having a hard time filling in all the boxes, or if you've got information that you haven't used, you're probably using the wrong calculator. All right, let's take a look at the third problem, which is Poisson. Be glad you're taking this class at a distance. Usually I make my students pronounce that. Most students call it Poisson, but it's Poisson is the right pronunciation. During a typical hour, fishing at lake, lots of fish, a fisher can expect to catch 3 fish. Find the probability that a fisher catches exactly 2 fish in the first hour of fishing. So first thing for a Poisson problem, what we're looking for is wording involving a typical, usual, average period of time. So here we've got a typical hour. I see the problem, find the probability the fisher catches exactly 2 fish. I know that x is equal to 2. But if I was looking for n in this problem, 2 out of how many? There's nothing in the problem that says that.
Right.
If what's the chance that a fish is caught? There's nothing in the problem that says that either. If you thought it was binomial, you're going to have a really hard time filling in those 2 boxes, and that's a good sign that you're in the wrong place.
So again, you were saying to distinguish between the binomial and Poisson. What again? Can you refresh on how be able? You say attempt something that has to do with time.
Yeah, you have to be
Usually might
given.
be
Yeah, so and that's the most important point. Some students set them up because they know they're not binomial, then they must be Poisson, but that's not a winning strategy, right? So
right.
we're looking for things like, in this problem, a typical hour during the usual day, in a typical month. You know, things that relate to an interval of time, we know what happens usually on average. That number is the mean for the time interval that we're given. Now with Poisson problems, there's also a trick where you have to make sure that the time interval that you're given matches the time interval in the problem. And we'll do one that does and one that doesn't.
Okay.
So here, what happens typically, that is your value of lambda. And so here, we expect 3 fish in 1 hour. Now we have to make sure that the question is asking about the same time interval. And here it says, find the probability that a fisher catches exactly 2 fish in his first hour. So the time interval in the problem is also 1 hour. So we multiply 3 by 1 or don't change it at all. The mean we're going to use in the problem is 3. So this is a Poisson problem with a mean of 3, and we're looking simply for x to be equal to 2. Again, the mean for the problem is 3. We want x to be equal to 2, and we get 0.2240. Now, this one's a little subliminal. Poisson is a French word. It was the name of the mathematician who discovered this, but it's also a French word that means fish. So if you see a problem involving fish, there's a chance that it's Poisson, but it's not going to be guaranteed either.
Good to keep in mind.
Yeah, because I think there's a problem involving the weights of salmon, salmon fillets or something like that. That was a normal distribution problem, so be careful. Fish doesn't necessarily mean Poisson.
Yeah.
Right. So, Toby, here's what I was saying in that last problem on a typical day.
Oh, okay. Yeah, I gotcha.
What happens in the normal, usual, I hate to say normal because we know we're going to see normal distribution, but in the usual, typical, average scenario, what happens? So in this scenario, they open 5 new accounts in a day. But the question here is about finding out what happens in the next 2 days. So the time interval is 2 days. And that makes the mean 5 times 2 or 10. Think of it this way. If the average for 1 day is 5, we would expect 5 on the first day and 5 on the second day. That's a total of 10. Right. So however many days there are, we multiply 5 by that number of days to get the mean for the problem. Okay. Here, we're looking for them to open exactly 6 accounts, so x is going to be equal to 6. And from there, it's pretty straightforward Poisson. Again, what you would write on your exam is Poisson, mean 10, x equals 6, and then whatever your answer is.
Oh, okay.
Here, the mean was 10. We're looking for equal to 6. 0.0631, rounded to 4 places. By the way, if you're panicking about, maybe panic's not the right word, but a lot of students get concerned about where they're going to round their answers to. Right. We usually do 4 places for these problems, but when in doubt, you can write more and that's not going to be a problem with me. Just be
Okay.
careful in my lab when you round them, because they're going to be pretty specific about where they go to.
Oh yeah, I
Uh,
mean,
One other thing I should mention, I know I was answering a question that Tracy had yesterday about where uh, it asked for you to round your answers to 4 decimal places, but the answer only actually went to 2 decimal places. You don't have to add zeros to the end of that. That would be fine. But if you put too many places, then it asks for, you could end up in trouble. So just be careful with that.
okay, we'll do.
All right, so that's Poisson. And there's 2 types of problems in chapter 7 when we talk about normal distribution: what I call normal probability problems, which we'll do first, and then reverse normal problems, which we'll do at the end. When we're reading through these problems, the first thing that we should be thinking about, can the variable take on continuous values? Is it a continuous variable? In binomial and Poisson, those are always whole numbers. But here, when we're talking about the heights of a boy, we know that heights are continuous, that decimals
Right.
are possible. That means that it can't be binomial or Poisson. The other thing that really helps with normally distributed, it will usually say that it's normally distributed, and you will always have both a mean and a standard deviation.
Okay.
In Poisson problems, sometimes they identify a mean, but they're not going to give you a standard deviation. Mean and standard deviation, that tells you you're in chapter 7, not in chapter 6.
Okay.
The mean is given in the problem as 29.8 inches, the standard deviation 1.2. And we're looking for the probability that a 12-month-old boy is less than 28 inches tall. Now, this creates a little bit of a problem that we're going to see in StatCrunch, because the choices that we have are either less than or equal or greater than or equal. You won't see less than in the list. In normal distribution problems, less than and less than or equal to mean exactly the same thing, because the probability that it's exactly equal to that one decimal value out of infinitely many decimal values is 0. But in a binomial problem, less than and less than or equal to are 2 different things, whether you're including that endpoint or not. So be careful going backwards. It's tough to get in trouble in chapter 7, but if you use that thinking back to chapter 6, it could be a problem. Let me hide the Poisson calculator. In the normal calculator, you enter the mean, which is 29.8. The standard deviation was 1.2, and we were looking for less than or equal to 28. It gives us the graph, but more importantly, the calculation 0.0668. And as I mentioned, on the part 1, you'll write normal for the calculator. You'll write what your mean was, what your standard deviation was, and then what your answer is. Oh, also, I'm sorry, you should also write what you use for x. And here I would have typed x is less than or equal to 28. The reason I have you do this is that if you make an error, it gives me a basis to award partial credit. So if, for instance, going back to the binomial problems, if you wrote less than or equal to 28, which was correct, but you used the less than sign, I know that it was an error in execution, not an error in thought. And thought errors cost more than execution errors. So what you're really doing is you're documenting what you've done to help me determine how much you understand. Partial credit is always based on level of understanding. And if I have to guess whether you understand or not, I have to guess that you don't. Right. So by documenting all of these steps, you're really playing it safe should some minor error occur. You know, I tell my algebra students, if you write that 3 times 3 is 6, I mean, if you're doing a problem and you multiply in your head 3 times 3 is 6 and your answer is way off, I have no idea what happened. But if you write down 3 times 3 equals 6, I can see where your mistake was. And my punishment is not because you made an easy miscalculation. You're going to show that you were doing the right steps. You just misfired. You should have used your calculator maybe. You want to document all that you can for your own grade's sake.
Makes sense. Sounds good.
Number 6 is pretty similar. I just wanted to show the use of the between tab. So here, the lengths of human pregnancies called gestation periods. Those are normally distributed with a mean of 268 days, standard deviation of 15 days. And we're looking for X to be between 254 and 261. And StatCrunch has a tab for that where it says between. So let's go to that. Just have to change out the mean and standard deviation. The most common mistake is not changing the mean and standard deviation, which will be defaulted as 0 and 1, or keeping the same mean and standard deviation from one problem to another. So just be careful with that. Okay. We're looking between 254 and 261. And we can see in the graph, it shows in that little red area there, that's the area that represents probability. 0.1450 is the right result. So I think there are 2 normal probability problems like the 2 that we've done here. Again, just tell me which calculator you used, what you typed in, and what your result was. Now, the last one is what I call a reverse normal problem. And I choose that phrase because we're kind of working backwards. Instead of being given a value and looking for a probability, I'm going to give you a probability and ask you to work backwards to the value. At first glance, it looks like a regular normal distribution problem, approximately normally distributed. I have a mean and a standard deviation of 100 and 15 respectively. We're told IQ scores are always in whole numbers. That is an important piece of information when it's time to round our answer. Then it says, Mensa, a group of people of high intelligence, requires that its members be in the top 2% on any intelligence test. What IQ is the lowest possible for admission to Mensa? So notice what it's asking for. It's not asking for a probability. It's not asking for a percent. It's asking for an IQ score. So we're looking for a value rather than a probability, rather than an area. So the first and probably the most challenging part once you get past there is trying to figure out whether we're dealing with the left tail or the right tail, a less than or equal or a greater than or equal to sign. And this one can be challenging because a lot of times students walk in on this word, but the key phrase here is actually over here. Yeah, we're looking 2%. For the top 2%. Go ahead.
No, that's, I said I caught that. Yeah, that's very important.
Yeah, so the top 2%. We're looking for the lowest one that sneaks into the highest scores. So the highest scores are to the right. So the sign that we're going to use for X is going to be the greater than or equal to sign. Oh, but we're going to leave that value empty, and we're going to type in the area. 2% is 0.02. By the way, that is another place where things go astray. Sometimes students will write 0.2 for 2%, but remember,
that's 20.
Yeah, that's 20%. 2 places for percent. So we move it 2 to the right. If we had 2%, we move it 1. Oops, wrong direction.
I got it.
1, 2 to the left. So 0.02. Okay. Also, keep in mind, you can always just divide it by 100. If you want to play it safe on your calculator, 2 divided by 100, you'll see the 0.02 right in front of you. True. So back to the Poisson, the normal calculator, going back to standard, I'm going to enter my new mean, 100. Standard deviation happens to be 15 again, so I'll leave that alone. I want greater than or equal to. I'm going to leave that blank. And then the last step is to put the area in the right-hand
Oh,
box. And so this gives me a value of 130.8. 130.8 on the graph is the part that separates the shaded area from the rest.
that 2%.
Yeah, to be in the top 2%, you've got to be in the shaded area. So 130.8 is what StatCrunch is giving me.
Oh, I got you.
However, that's not a possible score because we're
It has to
told
be whole.
scores are always in whole numbers. So then the question becomes, which way do we round? And the right answer is 131, but it's not for the reason that you might be thinking, right? Not because it's closer to 131. It's that 131 is the first value inside the shaded area. If we think about a number line of possible scores, 129, 130, 131, 132, 130.8 is right here in between 130 and 131. These are the good scores. These are the scores that work. 131 is the first score inside that region. That's why we would round to 131. If StatCrunch had given us an answer of 130.2, we would still round up to 131.
Okay. Yeah, I just got to be real careful with that.
Yeah. So the last thing in this problem, a lot of students, right, I mentioned talking about lowest, they're going to type less than, and you're actually going to get an answer of about 69 is your answer. You want to think about, is 69 an IQ that would be in the top 2%? And if the average, the mean is 100, we know that half are below 100, half are above 100, but 69 is not even in the top half, never mind the top 2%. Let me go back to the calculator. I did the same thing. Now take a look. Look at that group that it's sectioning off. Is that the top 2%? That's the bottom 2%. So you can use your reasoning to let you know when you've made that mistake as well.
That's just because
all the time.
You
Everybody's going to make a mistake, and we learn from our mistakes. The real key to success in math and statistics is being able to determine when you've made a mistake.
Right.
Okay. So that's the end of the problems for today. On the part one of the midterm, that covers there's like 7 problems at the end that now you can go ahead and do. I think the best strategy, as I mentioned before, is try the problems on the practice midterm.
Yes.
Check those to the answer key. If those answers are right, you're about as good as you're going to be. Do the problems on the part 1 of the midterm. After you do those, you can then move on into the part 2 that's inside of my lab. Do those problems that relate to that section. And then you can just close it by clicking on the red X at the top of the window. That will automatically save what you've done and let you come back and continue. You'll still have your 12 hours total time.
Okay.
One thing that we ran into as an issue yesterday is that if you're in the middle of a problem and you don't advance to the next one, it may not save your work on that problem. So either finish the problem completely or at least write down what your answers were so that you don't have to recalculate that part.
Got it. That makes sense.
The other thing about the My Lab part of the exam is that you do get 2 attempts. So your first attempt will go through. You'll get a score back. You'll see which problems you got right or wrong. Now you can go over the ones that you got wrong. Why did I get that wrong? What would the right answer have been? And then you can go back and take the test one more time. Again, the second attempt is a free attempt. Your score can't go any lower. It can only go up. So if you get 90 the first time and you're not happy at 90, take it again. If you score below 90, the 90 will stand. If you score above 90, the new score will be the good one. So try to leave yourself enough time so that you can get both attempts in before midnight on Monday. Also, for the 2 of you that are here, and I'll send out a notice about this, I saw that my math lab or my lab will be shut down for maintenance from 10 o'clock tonight to 6 o'clock tomorrow morning on the West Coast. So whatever you're doing today, you want to make sure that you wrap it up before 10. I mean, no good math happens after 10 o'clock anyway. But you want to make sure that you've got what you need. Also, it's a good idea, if you haven't done it yet, print out part 1 of the exam so that while my lab is down, StackCrunch will still be open. So you can still continue to work on those problems. The last few updates have gone really well, so I'm not anticipating any problems. But keep in mind that if Pearson does have an issue with the restart, I'm very flexible in terms of deadlines and so on. Whatever amount of time they penalize you by, like, I will more than make up for that. So if things get a little wonky in the morning, don't panic.
Sounds good.
I think that covers all that I wanted to cover. Does anybody have any questions or?
I'm okay.
All right.
Okay, right
This
now.
is sounding
Sorry.
promising.
My kids
So-
my kids irritated me this morning, so I'm like, that's why I'm being quiet.
Hey, that happens. I will
Same
be
here.
available by email, and Toby, I should mention this to you because Tracy, you send most of your emails through Canvas.
Yeah.
I do get notifications on my phone when they come through Canvas as opposed to regular emails. So like if you want to get a hold of me, the Canvas way is probably the best way. I see those quicker. So I'll be around throughout the weekend and through Monday. I'll try to continue to send out posts where I think of tips to be successful on this. And if anybody else has a problem with a certain particular problem, I'll make sure to share that with the class as well.
Thank
All
you.
right, yeah, you bet. I'll go ahead and stop the recording. Good luck this week, and good luck with everything you guys are doing. And stay safe and be well.
Thank you.
All right, take care.
Same to you. Thank you
Bye-bye.
very much.
Will do. Bye.